Okay, last of the video solutions for Module 2. This time we're going to look at solving absolute value inequalities. So this time we're going to look, and there's two different situations we need to take a look at. We're going to look at algebraic ways to solve absolute value inequalities. That's all we've done to this point. I will show you guys a little trick, how to use a graphing calculator to do this, which you'll be able to use on the graphing calculator part of the test. But more importantly, you need to know how to do this stuff without a graphing calculator algebraically. So that's the more difficult of the two processes. So we'll focus on that. So there's two different scenarios that show up here. One of them is when you have an absolute value expression that is isolated on one side of an inequality and it's less than a number. If the absolute value is less than a number, then you end up with making this kind of a trade. Just like before with absolute value equations, we're going to trade the absolute value inequality for two regular non-absolute value inequalities. But when the absolute value is less than a number, we get a compound inequality that's bounded on both ends. So this is what technically we call this a conjunctive compound inequality or an and compound inequality. But we're familiar with this from the stuff we did in Module 1. We know that this is where when we solve for x is going to have a lower boundary and an upper boundary to the values of x in our solution. So in the recipe for this is pretty simple. Whatever's in the middle of the absolute value bar, so what we call the argument of the absolute value function, goes in the middle, and then we're going to put positive c on the right because that's going to be the greater value, and negative c on the left because that's the lesser value. And then we'll just solve that compound inequality. The other scenario is when we have an absolute value expression isolated on one side of an inequality that's greater than a number. If that's the case, we make a different kind of a trade. Then we say that the argument of the absolute value function, so whatever's inside the absolute value bars, is either going to be greater than the number c, or it's going to be less than the opposite of the number c, so the negative version of c. And then we'll just solve both of those separately. As kind of a way to maybe remember which one is which, here's a little mnemonic device that you can take it or leave it, but it might help. Remember that when we solve an absolute value equation, we get an or in our answer. We get two separate solutions. And one of these two, the bottom case, we also get an or in our solution. So the one that's the oddball, that doesn't have an or, that uses an and instead, is the one in which the absolute value points at the inequality. So it's pointing out the odd one, the odd absolute value. Think of it that way, if that helps. Okay, so let's look at some examples. So here we've got the first type. We've got an absolute value already isolated by itself on one side of the inequality, and we've got a less than sign. So the trade that we make is whatever's inside the absolute value bars. So in this case, a negative 3x minus 12 is going to be less than positive 48 and greater than negative 48. Okay? And so all we've got to do then is just isolate x. To isolate x, we're just going to get the x by itself the same way we always would. Well, if we reverse order of operations, that's an A, to isolate the x, we're just going to undo everything that's being done to the x in this order. So first we have to undo addition and subtraction, so we'll add 12 to all parts. So then we end up with negative 3x in the middle. Over here we're going to get what? Negative 36, and over here we're going to get positive 60. Then we're going to divide both sides through, or all sides through, by negative 3, and we're going to end up with the number 12 here. We're going to end up with the number negative 20 there, and we get an x in the middle. But remember, there's a special rule that we're required to use when we're doing algebra with inequalities instead of equal signs, so inequalities instead of equations. Whenever we divide an inequality by a negative, or we multiply an inequality by a negative number, we have to flip the direction of the inequality signs. And so we end up with this answer. Now, this is written in the wrong order, though, isn't it? We know that we've got to put the smaller, like a number line, we've got to put the smaller number on the left and the bigger number on the right. So the negative 20 should go there, and the positive 12 should go on the right, and the x is in the middle, which means that we have to reverse the signs again. So it says the same thing as it did up here, but in the proper order. X is greater than negative 20 and less than 12, but the negative number has to go on the left, the smaller number has to go on the left, and the bigger number on the right. So this is our answer. That's what we've got to input. Okay, same kind of thing. This time we can see that the absolute value is by itself, and it's greater than a number, greater than or equal to, but we treat that the same. So that means we've got to make the other type of trade. Now, whatever's inside the absolute values is either going to end up being greater than or equal to, in this case, positive 16, or what's inside the absolute values is going to be less than or equal to negative 16. And we'll just solve both of those inequalities. Subtract 20 from both sides and get 2x is greater than or equal to negative 4. Divide by positive 2, so there's no reason to switch the inequality. And we get x is greater than or equal to negative 2. Or, what do we end up on this side? Well, we subtract negative 20 from both sides. We get 2x is less than or equal to negative 36. Divide both sides by 2, and we end up with x is less than or equal to negative 18. Okay, but notice in the directions that they don't really want us to use the word or. Instead, we'd rather use the mathematical symbol for or, which is on this drop-down menu. It's right there. Notice it says logical or when you hover over it. So we end up then with x is greater than or equal to negative 2, or x is less than or equal to negative 18. Okay, I think, well, I'll go ahead and do this. Just give you a little more stuff to look at. You can skip through this. If you feel like you got this down, just skip to the next one. So this time we've got an absolute value that's less than or equal to a number, and so we can make the first kind of trade, the and trade. The inequality is pointing at the special kind that doesn't use an or. So we end up with whatever's inside the absolute values. 4x minus 48 is greater than or equal to negative 52 and less than or equal to positive 52. And I'll just go through the process of isolating x. So I'll add 48 to all parts. I get negative 4, 4x, and 100. So then if I divide, and the inequalities stay the same, of course, I'll divide everything through by positive 4, so I don't flip the inequalities. And then I get an x, a negative 1, and a 25, and the inequalities stay the same. So that's my answer. Okay, I will go through this. There's something you got to be a little bit careful of on this problem. You'll see. So we've already got the absolute value isolated on one side. It's greater than or equal to, so we're going to use the OR trade, not the AND trade. And we end up with whatever's inside, which is a negative 3x minus 18, is either going to be greater than or equal to positive 48, or whatever's inside is less than or equal to negative 48. So we'll add 18, and we get negative 3x is greater than or equal to 66. Then I'm going to divide both sides through by negative 3, which means I'm going to have to flip the inequality, and I get x is less than or equal to negative 22. Or, over on this side, add 18, I get negative 3x is less than or equal to negative 30. Divide each side through, once again, by negative 3, so I got to reverse the inequality sign, and get x is greater than or equal to positive 10. Remember, I've got to use the OR symbol. I'm going to go ahead and stop here, and I'll add a second part to this video solution a little bit later, but I'll put this one up right away.